right, a new show and tell. Let's discuss my challenges and everyone's challenges of communications between your inverter and your battery pack. In the past, the inverter, the charger, all we had to do was hook it up and to positive and negative of the battery, and the inverter and charger knew the overall state of the battery by way of charge, the voltage. The voltage was all we needed was for the charger to know when it needed to go to bulk, to absorb, and to float. Now, the chargers and inverters, they don't know anything. We're basing it on a cell charge. It can be done. Devices like this, it registers, has the 9 pins, so it's able to figure out the state of charge of each cell individually, and then accordingly set the charge, slow that charge down so that the cells get to absorb. So it can be done. It looks like the route that most manufacturers and inverters are going. They are still on lead acid batteries. If you take any manual, 50% of it's based on how to charge a lead acid battery. But as the manufacturers of the inverters and chargers come along, they are looking at communication by RS485 or CAN bus. I'm a little hesitant on the complication of just charging or discharging a battery by actually having to get out a laptop. I'm also a little hesitant of having to download files from companies I'm not sure about. They might be just fully legit, but I don't know. It's a file. So the only way I'm going to do when I build mine and use a 480 or the CAN bus, I'm going to have a inexpensive computer, and that is just going to be strictly for that device. And then if I like the BMS, I'll keep the program. If I don't, I'll completely wipe the whole computer. Let's look at some of the challenges that everyone faces on that. None of these ideas or solutions are my ideas. I've been able to, like all of us, be able to explore, get on the forums. YouTube has been a great source of information on that. A lot of people who will do an inverter test never discuss this part of the point, and that part is really the safest part of it. How can we make sure that we're not overcharging our batteries, and not to have the chargers or the inverters just rely on that overall state of charge as opposed to the each cell level? We're going to go from kind of easier to harder, and I'm going to have a separate video on my batteries that I put into series, because obviously there's going to be a little bit more complication to that. Not complicated, just challenging. So let's start with the simplest, which is just an inverter type. This one here is an inverter type. This one here is just an inverter type. In between, we will go through this one just because it's just in the way. But anytime we go to a charger, I'll call out what the difference, because all these are really designed, they'll have some kind of a communication hub to it, but it's either charging or inverting. I can stop the charge or I can stop the inverting. The communication won't allow you to do both. Hopefully in the future we'll get there, or hopefully we'll get the inverter manufacturers to get back to the way it used to be, which is simple. I can just look at each cell. I do realize the hang up with that is the fact that, hey, most battery manufacturers don't create an ability for me to check or test those levels on the exterior of the battery. But this is just a clear DIY setup. I can do it, anybody can do it. We just need to have a port, and then we will get the actual hookup for it and do it ourselves. It only takes a few minutes. Okay, maybe a couple hours to do it, but it can be done. All right, enough rambling. Let's start. Sorry, got to continue rambling here. So I've got this little device. We'll have an overhaul shot of it, but it's basically my Electrodocus MPPT. There is 5 solar charge controllers. I'm going to do a separate video on this, specifically when we want to do the test for the solar panels. But for now, I'm using this as an example because then I can just easily transfer to all the batteries with just this one device. Now, when you're having this set up in your trailer, your boat, you're at home, everything's going to be nicely wired together. But I'm going to try to do it all in one take, plug, unplug, and just to show you that it can be done in maybe not one take, but hopefully we'll try to do this all in one take. Okay, so I've got the inverter, it's hooked up to the battery, cheated that way. Now, I'll give you an example of what I had to do here, which in this communication hub, which is this here. So, you know, you got the 4 pairs of stranded cable. So by splitting them all up, I have done this improperly, which is take the 2 wires and try to find the ones that will basically turn it on and turn it off. The better way to do that, of course, is with the meter and check for continuity. And then you won't do what I do anyways. So this is how I did it with this. And that basically works with this inverter. It pretty much works with all the inverters except for this guy here. And in this setup, when I get to it, you'll see that I just took the on and off switch here. And it's basically, this has the same communication port, but this just made it safer and easier for me because there was just simply 2 wires. And I knew which 2 wire it was once I took that out. And you'll see in this case, since I'm talking about it already, okay, that JST type connector. So pretty easy for me to make another JST connector and wire it into there. And that's all I did. All right, let's hook up the first one here. I've got a couple different ends on it because some are just basically a signal that is sent as an open or closed circuit. Others are set up for anywhere between a 3 volt, 5 volt to a 30 volt. It needs to see actual voltage. Well, in this case, it's just a small milliamp of power. And we'll see how well my crimps are if I don't pull one of these things apart, going from one to the other. So we're going to always, when I'm hooking it up, I'm always hoping that you'll be able to see the lights turn on. So once I hook this up, then I will take, all right, that was the first stop. Let's start again. All right, so let's do the wiring. And then we go down to external 5, and all I gotta do is turn that on. Okay, so inverter's on, and then if we had hit I've had this set up right now as a low voltage, so when this BMS detects that the cells are too low, and we're not going to worry about the overall state because one cell can be much lower than the rest if it's not perfectly balanced. So then it'll send the signal as an open circuit, and it disconnects the load. And that's pretty much purpose built for that. Okay, so that's that one. And then what I'm going to do is I'm going to take this little fan, and we'll just kind of go to each device. Okay. My plug-in is over here. All right, so we're going to do again the low voltage disconnect with this one. First, connect the battery up. And now, this is my low voltage, and then I'll show you how the low voltage is shutting the inverter from inverting. But this is an inverter charger. So now the inverter, let's say you got your trailer at home, and you're going to charge up your trailer. You're going to charge up the batteries before you go on your trip. Great. So as you plug it in and go to bed at night, you want to make sure that you feel safe and comfortable that the charger will shut off the charging function once the batteries cells are high enough. But this doesn't know each individual cell. Only a proper BMS will do that. But we don't really want the BMS to just disconnect the load. We want the BMS, just like they used to be, is to communicate with the inverter, well, charger in this case, to say, hey, I'm full, please shut off. So it ramps itself down. So the way, again, the problem with this is it only has one communication. I can either tell it to stop inverting, but I can't tell it to stop charging. So let's control the power that's going into the inverter. And we can do that. I've got this as an example as an extension cord, and I've got this through a solid state relay. And this is just a Mickey Mouse setup right now. You're going to take the time, you're going to have this mounted, you're going to have this mounted on a heat sink. And then I can control that solid state relay by this sending it a voltage, a DC voltage controlling the AC current. Okay. And all right, so you'll see no light on here, and you'll see this is off as well. So the first one I'm going to turn on will be this guy here. Okay, I'm on, and then please note this one here, and the fan is on. Oops, go to 1. And now I'm allowing the charger setup to charge the batteries. Okay, and then the charger says at 4 in the morning, hey, my batteries are fully charged up, please shut off. Boom, your AC is now shut down, but the inverter function is still going. So that's the nice part about it this way. You really don't want your inverter to shut off when the batteries are full. Maybe you got your fridge going, or other things that are in the trailer or boat or at home. And then I'm going to go back to 0, and I'm going to tell you, so now you're in your trailer, you're at your campsite, you've been there for a few days, you're not keeping up with your demands, and now the batteries are being drained. So hey, you got to shut off. So tell it to 0, and then it shuts that off. Okay. All right, are we free and clear? Disconnect the battery. All right. And again, you can see the advantages of having Anderson connections. I'm not worrying about getting polarity mixed up and then ruining an inverter. So 12 volt again, hook it up. Now I've got power to the battery. This one's straightforward because it's just inverter, but it does have a communication port, but it also has this open or closed circuit. So we'll take advantage of that. There's no charger based in it, so makes things a little bit easier for setup wise. So I'm at 0, 0. Okay, now I'm going to turn that function on. And make sure you want to look for that light, and then of course what I'll do to really signify that it's on, I'll plug this in. Okay, and then I'm going to communicate with the inverter to say, hey, my battery cells are almost low, please shut off. All right, now we're going to one challenge. We're going to go into that's different now. We're going to go into a split phase inverter. And the challenge with the split phase inverter is that I have two hot legs. So how do we control two hot legs with that solid state relay? Again, 12 volt battery. Got to do this in a right way or this thing complains. So we might have to do step number 2, but let's just, or take number 2, but let's just see if we can do this. Okay. Now, I'm going to plug this in. So this is to a dryer. Okay. Not like a fifth, it's just a dryer. Look at that. But we got two hot legs. So here's the solid state relay over here. Again, this is Mickey Mouse setup, but it's safe enough for what we want to do. This is not long term or anything like that. I've got my two hot leads and my ground here, okay? Now we'll connect this up with the same type of input. Okay, no light on yet, and then, so this is going to stop my inverter charger from charging, and then this input here, and this is the same thing where it says remote switch, and it's just an open or closed circuit. And we'll hook it up this like so. Okay, there's my DC going in. Now I'm going to tell this to turn on, maybe. I'm in the off position, and I have the AC breaker on. Oops. Okay, so you can see the inverter turned on. And then if you go take the camera, now we're going to show again the charger on. So now the charger is sending power to the battery, the DC battery. Okay. Off charging. Now it's just on inverting, and that's the function I do like, is the fact that once we turn one, we're not, you know, like you can either tell the inverter to turn on or off when you're inverting, but if you wanted to do the same issue with charging, it would be really, like I'm repeating myself, there would be a real dysfunction if it would shut the whole inverter off when you wanted to stop charging. That would defeat the complete purpose for it. And what's nice is if you have it set up so that once you unplugged, it would just go to the inverter, and once you plugged in, because you would keep that signal still closed, so that when you plugged in with power, it instantly start charging. And of course, then you're setting it up to whatever way you want with your inverter. Some of the inverters, you can get a lot more fancier by the settings that you can set it up. Okay, so I'm going to leave it at that, and then next video will be about doing the 48 volt with two batteries in series. So then we got to series the communication. I'll leave it at that.